In this video, we will focus on the term procedural modeling. We will discuss different types of programming paradigms and different types of parametric modeling approaches. In the process, we will define what we mean by procedural modeling. First, let's take a look at the Wikipedia definition of procedural modeling. It describes a particular perspective from the computer graphics domain. It involves defining rules for generating 3D models. The Wikipedia page also gives some examples, such as L systems. The article is good and covers some of the key ideas. But the perspective on procedural modeling within this course is a little different. Let's discuss 3 key aspects relating to the perspective we will be taking. 1. A focus in the built environment. 2. The idea that it can be used to support design decision-making. 3. And the aim to empower the end user to write their own algorithms. First, the modeling that we do in this course will focus on man-made structures in the built environment. We will work at a number of different scales. We will start from the building scale, then later to larger urban scale. Second, an underlying idea in this course is that procedural modeling can be used to support design decision-making. The ability to quickly generate design options and variants allows for a different type of design exploration. Third, the aim is to empower end users to write their own algorithms. We assume that these end users will have had no previous training in programming. Finally, we should also manage expectations. We must start slowly. You will be learning the fundamental building blocks required for writing your own algorithms. However, it will take some time to learn. So the models that we will be generating in this course will be quite simple. Later in the program, the complexity will increase. Next, let's look at a few topics closely related to procedural modeling. First, we will look at some different programming paradigms. After that, we will take a closer look at a number of different parametric modeling approaches. In order to create a procedural model, you will need to write an algorithm. We will refer to this process as coding. To code, you need to use a programming language. There are 2 broad paradigms: imperative programming and declarative programming. Imperative programming is lower level. The code you write gives very detailed instructions to the system. These instructions will orchestrate every aspect, including the flow of execution and changes to the system's memory. Declarative programming is higher level. The code you write describes some outcome that you want to achieve. The system will then figure out the detailed instructions required to achieve that outcome. Most programming languages are imperative. For example, languages such as Python and JavaScript. We will also be using an imperative programming language. We can drill down deeper into more specific categories. The next level down is structured programming. Structured programming makes extensive use of control flow constructs. These will be discussed in more detail later in this course. They include conditional constructs and looping constructs. If we drill down one more level, we arrive at procedural programming. Procedural programming also uses control flow constructs. But it has an additional emphasis on breaking down complex programs into smaller chunks of code. These chunks of code are defined as procedures or functions. The code inside the procedures and functions are isolated from one another, thereby reducing the chance of bugs and errors. In this course, we will be using a procedural programming approach. Now let's look at parametric modeling. Parametric modeling is a broad term that encompasses many varying approaches. In general, we can say that parametric modeling allows users to define algorithms that generate models. There are many different types of parametric modeling applications available. Many of these applications have visual interfaces for creating such algorithms. Here are 4 parametric modeling applications, all using a node-based programming approach. When the algorithms are executed, a model is generated that is then displayed in a 3D viewer. Such an algorithm typically calls various functions in the host system. For example, functions for creating and modifying geometric entities. The algorithm will also define different types of variables. Independent variables can be exposed as parameters to the model. Such parameters may be presented through a user interface. The parameters can be used to generate variants of a particular model. In the example shown here, 4 different spiral staircases have been generated. Each staircase is generated by the same algorithm, but with different parameter values. This approach is powerful, as it allows for the rapid generation of model variants. This can support design space exploration using a rapid iterative virtual prototyping approach. Parametric modeling applications vary in the programming constructs that they support. One powerful construct is the ability to iterate using some kind of loop. As we already mentioned, with textual programming, these include, for each, loops and, while, loops. In the example shown in the diagram, a loop is used to replace each polygon in the model with a set of diagonal tubes. Parametric modeling applications can be categorized based on how they support iteration. 4 broad categories can be defined: object modeling, associative modeling, dataflow modeling, and procedural modeling. Object modeling does not support any iteration. Associative modeling supports iteration, but with loops that contain a single operation only. Dataflow modeling supports implicit iteration through structuring of lists of data. Procedural modeling supports explicit iteration using looping constructs. The explicit approach used in procedural modeling gives greater control over the iterative process. In this course, we will be focusing on this approach, using typical looping constructs. To summarize, procedural modeling integrates procedural programming with parametric modeling. The procedural programming approach enables complex algorithms to be written. These algorithms can explicitly define the control flow using conditional constructs and looping constructs. The parametric modeling approach integrates with a 3D modeling environment. This environment supports various tasks, including setting parameters, executing algorithms, and visualizing models. In this course, the procedural modeling exercises and assignments will all be performed using Möbius Modeller. Mobius Modeller allows you to define the overall structure of your program as a flowchart. You can then define your own customized procedures for each node in the flowchart. At first, we will focus mainly on writing these customized procedures. The flowcharts will all have only 3 nodes: start, node, and end. And the procedures you write will all be inserted in the middle node. Later in the course, you will create more complex flowcharts with multiple interconnected nodes.